for every 1 to 3% of all the fuel that's consumed in ships turns into this oily residue sludges, which is either illegally dumped at sea, incinerated for no value in the ships themselves, or at very best sent to a cement kiln or to incineration for electricity generation, things like that.
Good morning, good afternoon, or good evening, wherever you are in the world. Welcome to episode 251 of the Climate Confident podcast, where we focus on what actually moves the needle on decarbonisation, not the glossy brochures. I'm your host, Tom Raftery. My guest today thinks the fastest way to cut shipping emissions isn't by reinventing ships, but by reinventing fuel. Nicholas Ball is the CEO and founder of XFuel. Nicholas, welcome to the podcast. Would you like to introduce yourself?
Yes, thank you so much, Tom, for having me on the show. So yeah, I'm Nicholas Ball, and I'm the CEO and founder of XFuel.
XFuel, okay, great. And tell us a little bit about XFuel, Nicholas. What is it? Where are you based? That's interesting. What is it you guys are doing?
Yeah.
And a little bit of the why. We'll get more into that in a minute.
At XFuel, we essentially develop and deploy technologies that can turn various types of waste materials into low carbon drop-in transport fuels, specifically for shipping, heavy good vehicles and aviation sectors. And really the whole meaning of our company is to avoid the need to, basically using the carbon above the ground to avoid the need to kind of drill, extract, refine, transport and combust brand new fossil fuels. We are a multinational company. Our headquarters is based in Ireland, but most of us are based in actually Spain, in Mallorca and the Balearic Islands, where we have our R&D center and developing our pilot plants here.
So let's start, Nicholas, by setting the scene. Shipping moves about 90% of global trade. Pretty much everything that's on my desk here was in a ship at some point, I got to think.
I would say one of the biggest challenges is just the energy density of what ships use, which is basically fuel oil, right? And then the product itself that they're consuming. It's very hard to replace that, not to replace it at all, but to replace it with something that is price competitive and actually comparative in the market. So I would say that's one of the biggest concerns and one of the biggest issues in the shipping sector. And a lot of people say it's obviously hard to abate. And also I hear this a lot in conferences and with different speakers, potentially one of the last sectors to be decarbonized just because of these particular difficulties. But we're trying to tackle those challenges in different ways and in innovative ways. So hopefully we're on our way. Let's see.
And is it mainly a cost issue, or is it more about infrastructure and regulation, or something else entirely?
Well, so infrastructure is obviously a massive point. So what we do at XFuel, just to kind of compare it to what you would typically have with different or alternative fuels, is that we work with drop-in solutions. So they comply with fossil standards. They can work with existing infrastructure, both engines, but also logistics and all of that. Comparatively with other kind of technologies and other usual contenders out there would be like the methanols, the ammonias, different kind of transport fuels that people are looking at, the hydrogen or hydrogen-derived fuels, is essentially the infrastructure question, as you mentioned. So there is no infrastructure right now currently deployed for this. There is massive amounts of confusion of which infrastructure to deploy in ports, which one is the contender, which one should be used, not used. We don't want to be doubling up and deploying multiple types of infrastructure for multiple solutions either. And that's a big issue. And then, of course, the economics, right? I mean, I would say that shipping is probably one of the most price-sensitive industries I've ever come across in my life. When we're looking at fuels that can be anything from 3 to 5, 6 times more than fossil fuels, and that's a massive issue. And so what's helping with that is regulation. But yeah, regulation is not quite there yet in terms of it's not so consistent. It's not so dependable.
Yeah, sure. So let's, against that backdrop, let's talk about the idea that you ran with. What was the light bulb moment that led you to create XFuel? Was it frustration? Was it a lab experiment gone right, or was it, something else?
We've been developing technologies to work with waste materials for a long time. So at its core, the technology was developed, more than 10 years ago. It's probably like 12 years ago now. And really the frustration at that time, as you can imagine, there was no regulation. In fact, climate change wasn't even on the agenda for most countries and politically around the world. So our frustration was that we truly believe that the only way to have adoption in any low carbon product was to be with price parity with fossil fuels.
Mm.
That was our kind of moment of like, okay, we have to achieve something in this space. It's a hard thing to achieve, obviously. A lot of people have been working on this, but that was kind of our North Star and what we were trying to aim for. And so we've been developing technologies that can turn different waste materials into drop-in products and with different sustainability profiles and different price points. And so I would say the beginning phases of our technology and some of the other ones that we've developed didn't quite hit that mark, right? So there was always that premium, that green premium that we had to achieve and people would have to pay for. And it's only more recently where we've been experimenting with other types of waste materials where we can actually get kind of below that. And that's really what led us to continue developing our technologies and wanting to bring them to market. It's that moment of saying, okay, for us to actually have impact in this industry, we're going to have to develop something that actually is a contender to fossil fuels on a price level. So that's what all our members and our co-founders that have had our North Star, or let's say have looked at being the main reason for developing what we do.
And what you're doing is you're taking waste that's usually costly to dispose of, even sludge from ships, and turning it into a drop-in fuel. How does that work in plain English, if you can?
Yeah, sure. So in the beginning of our journey, we worked with agricultural residues. So lignocellulosic biomass, woody biomass, basically.
Yeah.
Agricultural residues, it can come from forestry residues or all of these types of materials. And so the first technology we kind of were developing at the time, and we have a big pilot plant here that can kind of process this or co-process this with other waste oils and turn that into a drop-in product for the shipping sector, but at a price point that would be at a high price point. And the emphasis here is to avoid the need to break down the material to what would be known as a gas phase. So for your viewers, typical approach would be gasifying this material and then using Fischer-Tropsch or some kind of way of building out those molecules to produce the product that you have. And the issue with that is it's extremely energy intensive, extremely expensive. The equipment that you need to do that is also typically very expensive. And so the economics never really work out very well in your favor.
Right.
In our case, what we're trying to do is kind of remain a liquid phase as much as possible in the different technologies developed. And so with this biomass, we got there, but it was still a premium product and something that we realized the shipping sector wasn't that interested in. So on the back of that, it's serendipitous, but we developed another type of technology to take that biofuel and turn that into road fuel standards. So typical diesel, you'd have petrol stations. In Europe, it's called EN590, as well as other aviation fuels. And the only way of doing that today is basically depending on oil and gas, right? Hydrotreating, refining technology, standard refining technologies. And so we developed a second technology it's what we call clear CLR, which is a kind of very different refining approach to taking these hydrocarbon liquids and turning them into high quality products. And the reason why I tell you all this, Tom, is what we realized with this refining technology is we can actually use a lot of different waste materials without the biomass, without the first technology I was telling you about. And so we've found other waste materials that other people are not really looking at. One of which is residues from the ships themselves. So it's taking these kind of wastes. For example, maybe people are not aware of this, but for every 1 to 3% of all the fuel that's consumed in ships turns into this oily residue sludges, which is either illegally dumped at sea, incinerated for no value in the ships themselves, or at very best sent to a cement kiln or to incineration for electricity generation, things like that. So we were able to take this kind of waste materials, oily residues, sludges, and turn them into fully compliant products, marine gas oil products for the shipping sectors, road fuels, and potentially aviation fuels as well. And so that's the kind of waste and the kind of technologies we're working with. And the motivation with using these kind of waste is that we could get to a point where our price of our product was below fossil pricing and still deliver up to 85% greenhouse gas savings from a well to wake basis. Very compelling product, one that sold itself, drop-in product, they're already being purchased by shipping sector. And obviously meeting regulations as well, which is important. So yeah, that gives you an idea of kind of what we do, the different technologies we've developed. And obviously there are others in the pipeline and other waste materials we're working with, but it's our unique selling proposition, right?
Yeah. I mean, basically you're taking waste, garbage, you're turning it into, let's call it go juice. So
Yes.
it reminds me very much of Doc Brown in Back to the Future with the DeLorean, and he taking the rubbish out of the bin and putting it into the DeLorean and flying off into the sunset.
Yeah. Yeah, exactly. I mean, we haven't got quite to that level of garbage, although I think that's something we are discussing internally in terms of what are the most difficult types of waste that we could apply our technologies to. But the emphasis of our company is always the same. We realized very early on that to have real impact, like true impact in the industry, we have to have a product that has an interesting sustainability profile, so actually saves GHG savings, from an LTA perspective, and that we have to make sure that product is adopted. And I think most people forget about that part, right? Like, you can have the most sustainable product in the world, but if it doesn't get adopted for economic reasons or for other reasons, you achieve no impact.
Yeah.
Right. So what we've decided is exploring those boundaries and say, okay, well, maybe the type of waste that we're working with, like, for example, this oily residue is in theory a fossil waste, right? So you could argue, okay, well, how much impact can you have here? But ultimately, if you're achieving this at price parity or selling at price parity of fossil and having true adoption of this product, you are having a real impact. And so this is where we're working with different waste materials and finding that balance where we actually have adoption and purchasing of these products to have real impact, rather than delivering a product that no one will buy at mass because it's too expensive, for example.
And what about results? What's happening on the ground today? You've claimed up to 85% lower greenhouse gas emissions compared with fossil diesel. How do you verify that? And what does it mean for ship owners? I mean, you said yourself, you're taking essentially what is a fossil fuel and turning it into a fossil fuel. Granted, a waste product of fossil fuels, and turning it into fossil fuel that can be used. So talk to me about that.
The regulations that we use are typically they're not the mandatory, right? So we're talking about regulations that actually have to be used in the shipping sector. So in this case, it's fuel, maritime, EU ETS, things like that. So they state and stipulate very clearly about what the calculations have to be done to achieve GHG savings. And there are certain thresholds you have to meet. In this case, it's around 70%. And so the intuitive thought about this is it's what's called a recycled carbon fuel, by the way, just to be clear. So it's called an RCF. And RCFs are typically thought about as taking gas streams usually. So imagine if you are emitting something from a cement kiln. Some companies will take the emissions and try and capture those emissions and then repurpose them into a fuel, right? But the regulation also allows for liquid waste streams, as long as you can prove that whatever they're currently being used for is so terrible and so pointless that if you can repurpose that waste stream into an actual product, you're avoiding the whole value chain of, like I said before, like the drilling, the extraction, the refining of brand new fossil fuels. And so in this case, and what we've done our validation with SGS for our fuels is showing that actually in one of the best cases is that you're burning this for the generation of electricity. And that's a very inefficient process. Burning waste to generate electricity is a terrible approach compared to other approaches. And so if we can repurpose that into a very high value product, we can save up to 85%. There are better use cases, by the way. So we're working with big shipping companies around the world who burn this on board for no use. That's obviously the worst case, right? And in fact, there's an even worse case from an environmental perspective, which is illegal dumping, which has been shown to happen even in EU waters quite regularly of this material and other oily residues, not just this material. You're showing the whole value chain of saying, okay, well, what's currently happening with this material? If it's being burnt for electricity generation, what is the emissions that we take for replacing that electricity? So we have to account for that. We have to include that in our emissions as well. So we're saying, okay, we have to replace that generation. We have to obviously look at all of our value chain, our production emissions, if we have any, depending on what we're doing, transportation, all of that. And this is how we get to 85%. And we essentially compare that final number to a brand new fossil fuel, which is in the EU 94 grams of CO2 equivalent per megajoule. And then we compare that emission statements. So, okay, what are the savings here? And so that's an important process. We take it very seriously. We get it certified by ISCC EU plus, depending on the products and what we're trying to do. It gives you an idea of what we have to go through and what hoops we jump through and ensuring that it's truly low carbon products that we produce it.
And we've referred to it several times as a drop-in product. Essentially, that means no changes to the ship's engines, you can just swap it in and sail away, zero problems.
Yeah, that's an incredibly important point and why we do what we do. The products we produce are true drop-ins, meaning they comply with existing fossil standards. And currently, for example, marine gas oil, which is the product we produce, it's around 20-30% of what shipping companies would purchase anyway. So essentially, being able to buy our products, which has been tested in engines, it's been tested with blending studies with other sustainable products, other fossil fuels, and shown to work as well, if not even better than standard fossil products. We essentially can be used as a drop-in replacement. We can be blended, we can be used as is, we can be traded in the market as it was. And so that makes it extremely interesting for shipping companies because most sustainable products require not only the infrastructure change, not only the engine changes, retrofitting, which is extremely costly and in many cases unknown to be the right fuels, and you have to make that decision early on. It makes this a product that we use in transition immediately, right now, delivering impact today, which is a very valuable point for our products.
And you mentioned at the start that could be suitable for aviation, road haulage, or maritime, but you're focusing in on maritime. Why that as opposed to road haulage or aviation?
So as a company, and as me personally, but as a company as well, we truly believe in the electrification and everything we can do globally. Like we are not advocates of fuel for everything, right? That is not the intention. I know it sounds crazy. We're called XFuel, right? And that's what we do. And we've been doing that for a long time. But the numbers don't lie, and we're scientists and we're engineers, right? So electrification is by far the best way to decarbonize every sector that we can. The reason why we're going with shipping and obviously in the future aviation is because they're the most hard to abate, the hardest to decarbonize by a long shot. It's actually an interesting statistic. So when we've obviously done a lot of fundraising over the last 3-4 years. When we looked into the data from the IEA, we found something really interesting, a little bit depressing, but interesting. And that was that oil consumption for shipping and aviation specific. So if you take those two data points outside of the general transportation sectors, oil consumption is actually projected to increase 60% by 2050. And that is something that people are not quite understanding. And it's a mixture of reasons, right? It's hard to abate, but also growth in those sectors. We're not stopping to transport goods around the world. But also, at best, even if we met all pledges fully on time and fully, pledges, not what's in policy, but actually just pledges, we would only reduce it 15% by 2050. And this was already a year ago. So I'm sure those numbers have been updated. And given where we are with the US, it may be even worse today. I think when we realized that actually our focus has to be those sectors, really, because even heavy good vehicles, we're seeing some movements in battery technologies, electrification, where could be interesting and could get there. But that's not to say we can't produce that product, and we can produce other products. We can produce for passenger vehicles, no issue, right? It's just diesel. But we just don't go after those sectors because we just don't believe in them. So yeah, that's the reason, really. It's a mixture of technical reasons, but also just fundamental beliefs of what we think should happen in the decarbonization journey in transportation.
And you mentioned you've got that pilot plant that you're operating at the moment. What's your pathway from going from pilot to powering all the world's ships?
Yeah, it's definitely a difficult pathway for anyone that goes down this route of actually trying to make and deliver an impact in the sector. So we have 2 pilot plants deployed. We're commissioning another one right now as we speak, in fact, that you might hear some background noise. We're on site. But we are now moving to a commercial activity. So we're building our first commercial facility right now. We recently got funded by the EU, as well as some other capital that we've managed to secure earlier this year. And so we're going to build our first commercial facility. It's a modular facility. All our technologies we try to modularize for reasons of financing and others, which we can go into later. But really at this scale, we're moving to a single module, which can produce around about 14,000 tons per year of product for the shipping sector, from around 16,000 tons of waste. That's what we're looking at. That journey takes a long time. It takes engineering efforts. It takes a lot of different things as we're moving towards commercialization. but we're excited about the next phase of commercialization and where we're going to go next. Yeah.
Okay. What kind of time frame are you thinking of for this scale up?
So for our first commercial facility, we are aiming for the end of next year, end of 2026, and then more scalable production by beginning of 27. That's our timeline. We are looking and have a number of projects around the world that we're developing with different partners, and quite excited about the phase of development after that as well. We want to get our first one up and running to kind of iron out the kinks before we go out for a second round of multiple projects. And I think that's also quite interesting with what we do in terms of the project are very much globally distributed, just like shipping is and just like waste is, which is a decentralized feedstock in many ways. And then, of course, the replication of the modules is what should make this easier as we scale this out and be able to move faster later on.
And if we were to fast forward 5 or 10 years, where do you see the advanced drop-in fuels fitting in alongside the likes of hydrogen, ammonia, and the other e-fuels that we mentioned earlier?
Well, I'd love to get your perspective on this because I've listened to a couple of your podcasts, but obviously, and not just in preparation, but even before. So I am a listener. But I think the issue that I'm seeing is for the other alternative fuels to be contenders, and I wish this wasn't the case, is that we essentially need a lower cost energy, right? So they all depend on low cost energy to achieve what they achieve, and ultimately it all comes down to production of hydrogen as well as the capture of carbon of some form. That doesn't matter whether it's methanols or whether it's ammonias in many sense. The issue with that is I just don't see that coming fast enough in the time that we need. In fact, if anything, I see that every time that we produce more energy, we find ways of consuming more energy, AI being a great example today.
Yeah.
And so I see this kind of crash where I don't see where we're going to actually decarbonize aviation or shipping anytime in the timelines that we need. And so I think of us as a backstop. I think of us as a transit at this stage of what the materials that we're working on. We're obviously working with longer term, large scale or larger scale feedstocks that we hope to bring to the market as well. But I think of us as like a backstop to that industry and trying to approach waste feedstocks, advanced feedstocks, and achieving advanced bio and advanced recycled carbon fuels to the sector that are interesting from a price point and that can actually deliver impact. But do I believe we can develop a technology or develop a company that can decarbonize the entire industry? I don't think anyone can say that. That's a multi-trillion-dollar industry. Just being open and honest though, Tom.
Yeah.
But yeah, I'm not sure what your thoughts are on the energy side and the transition there.
Yeah, I think hydrogen is an expensive distraction, frankly, and the fuels based off of hydrogen. It's massively, massively inefficient. If we were to use green hydrogen to create fuels, you're talking about, let's say we're taking wind as an example. You need 3 wind turbines, just picking numbers out of the air here, to create the amount of hydrogen to convert into a fuel versus an electric one. If you went straight to electric, and I know we haven't got electrics, powering big ships yet, but I think that's where we're headed eventually. A single turbine would get the same amount of traction if you're going direct wind turbine to electricity versus the 3 turbines you'd need to make the hydrogen to send the ship the same distance. It's that inefficient.
Yep.
Electricity is 3 times more efficient, and you said it yourself earlier. So I think hydrogen is a distraction. It's an expensive distraction. It's a handy distraction for the fossil fuel companies because they make most of the hydrogen today with methane reforming. So they're pushing it. But I don't see it long-term happening. And we're seeing it in land transportation where cars are shifting to EVs. 10 years ago, when the Nissan Leaf, or probably 14 years ago at this point, when the Nissan Leaf first launched, it could go about 70 miles, a little over 120 kilometers on a single charge. And the new Leaf that's coming out this year can go 480 kilometers, 300 and something miles on a single charge. That's how the battery technology has advanced in that short space of time, 10 to 15 years. And the price point is still the same for the car. And because of that increase in the quality of the batteries, we're seeing now road haulage shifting to electric. I mean, again, you had this whole distraction around hydrogen and people built hydrogen trucks.
Yes.
We had that whole fiasco.
Yes. Yeah.
And buses as well. And any pilots that have gone out on those have failed miserably because the economics just doesn't work and also the infrastructure isn't there. Whereas electric trucks are coming on in leaps and bounds now in China. And of course, where it happens in China, it'll happen in the rest of the world a few years later.
Definitely.
And I think the maritime sector will see the same thing just a decade or so later. So I think we're heading to the electrification of shipping transport, initially like with road transport for the smaller ships, and eventually longer term, we'll get to the container ships as well. I mean, the container ships is probably even easier because you just take a couple of containerized batteries and, they take the place of a couple of the containers and you're off. And when you get to a new port, you just swap out, the container batteries for new container batteries, and it's a swap and off you go.
In theory, I mean, I think when you look at the energy consumption of liquid fuels in a container ship, it is massive. It's an enormous amount of energy that's being used just for a single journey. I can't remember the exact numbers from equivalent of an entire country's day consumption in Europe, a small country in the EU. I think it was something crazy like that with the latest comparisons there. I think that battery technology will take, if it ever does, will take a very long time to make that economically viable. Because of course, with the energy density of fuels themselves, or fuel oils specifically, it's just so high that to achieve something like that or remotely near that from battery tech for shipping will be very difficult. And the same applies for aviation, because of course the weight obviously matters as well, right? I mean, we're talking, and size, right? So of course, liquefying hydrogen or whatever it is we're going to be doing, or pressurizing, I should say, it's a whole nother ball game. So I think, I agree with you that we're going to have advances in those sectors, which is why heavy good vehicles has not really been, for us, a major contender, or passenger cars, right? Because it's the same product, right? It's diesel. All these modes of transports are obviously consumers for us in many ways, but it just doesn't make sense longer term. And hence why we're kind of going with the shipping aviation. But completely agree. And I think, the numbers obviously don't stack up in terms of the inefficiencies in producing kind of a hydrogen-derived fuel. I've had this conversation with other people in terms of, even if we're producing renewable energy, where should that really be going? It should be decarbonizing our grid. It should be decarbonizing all the industries that need it, not using it for a liquid fuel today, at least. If we found if we became in a place where we had an abundance of renewable electricity, then I think the argument could be interesting. It'd be, okay, maybe this makes sense. But I think we're not there and we won't be there.
Yeah, the trouble with that argument, though, is if you have a place with an abundance of renewable electricity, then it's unlikely that you'd have an abundance of renewable electricity 24/7. And if you want to
then it's just about
if you want to run electrolyzers economically, they have to be running 24/7. And so if you're only running them 8 hours a day, you've lost 66% of their well, you've increased their ROI twice, two, 3 times. So
definitely,
it makes
there
no
are technologies
sense.
that are looking at the kind of on-off kind of electrolyzers. But I think we're missing the point there. I think just because you have excess renewable energy in a place, the issue is then it shouldn't be in that place, right? It should be kind of infrastructure changes, grid, baseload, battery tech,
That's
right?
it,
It shouldn't be, let's use it for this.
Yeah.
So I think that's where I lose that argument a little bit.
What's happening today is where you do have an abundance of renewables, places like Scotland, for example, with wind, you're getting the wind curtailed. And that's a problem, as you said, of it being in the wrong place. What you do there is you build interconnectors. And the argument that people put against renewables is the wind doesn't always blow and the sun doesn't always shine. And that's rubbish. That's absolute rubbish. Yes, the sun does always shine, and yes, the wind does always blow, just not always in the same place. But the 24 hours a day, the sun is shining. So you just need to build interconnections and you can move that electricity. China are building massive HVDC cabling to move gigawatts of renewable energy out of the desert into the places where it needs to be used. So you're right. The abundance argument is fallacious.
Yeah, it is. And then, by the way, they will be that we need hydrogen, right? We use hydrogen today, right? I
Yeah.
mean, the biggest use of hydrogen is obviously in our production of fertilizers, right? And ammonia. If anything, it should be used to decarbonize those sectors first. I think rather than be used as a fuel, which is in itself is inefficient, right? So I'm a big advocate for producing green hydrogen, but for the right reasons and obviously for the right places. The second biggest use of hydrogen, I believe, is in refining, right? So it's treating our liquid fuels and hydrotreating such. The other kind of implication of using less liquid fuels is, of course, that we would need less hydrogen anyway. And the question is that we could green that and put that into fertilizer production rather than turning it to a liquid fuel or fuels in general and burning them, which seems crazy, right? But anyway, there's a bit of a tangent there, Tom, but I wanted to get your opinion on that because it's an interesting discussion.
Yeah. Coming back, as you said, off that tangent, what would success look like to you personally by 2035, say?
2035. Success for us is essentially being a major contender, a major leader in low carbon drop-in fuels for the transportation sector. And I think that there is a massive gap in the market where there are basically two options, right? You either are going for something that we all know, the very expensive options, or you have not put your eye on the ball, which would be the fossil industry, the oil and gas industry, which have completely kind of moved off renewables more recently again. It seems to be going back and forth here. And so I think there's a huge gap in the market for us to be able to take as a market leader in that. I think the closest company to us is something like Neste, right? Who are producing kind of sustainable renewable fuels, things like that. But yeah, that would be a success for me, is being a market leader in that industry and providing real options to customers that have no options. Like the shipping company does, and not all of them, right? But do want to decarbonize. They do see that this is an important step. They just also don't see how this is going to work if they suddenly have to pay 3-4 times more for their fuels. And who's paying for that extra, right? Yeah. Is it the end consumer? Is it? So this is the issue. So yeah, that's where I see success.
Fair enough. You've built a company on the belief that innovation can clean up some of the dirtiest industries. What advice would you give to other entrepreneurs tackling climate challenges?
Oh, that's a big one. So I would say first one would be focus on economics. I think we already covered this topic in our discussion, but again, you can have the most sustainable product out there, but without the right economic case and the price point, then you'll have no impact. And obviously in that case, no success probably. And there's a great post by Extantia. It's one of the venture capitalists in the space and climate tech who have this priority list, and they say what startups sell. And at the top is kind of sustainability, and at the bottom is price. And in between there's kind of resilience and other things there and performance. And then in the other side, it's like, what does industry want? And it's completely the reverse, right? At the top, it's basically price. At the bottom, it's sustainability. So I think understanding those priorities is really important. The other is around fundraising, around sizing your projects appropriately, making sure that you can actually get them off the ground and actually have impact. So don't go too big, don't go too small. And all that journey around fundraising, finding capital, whether it be through grants, whether it be through obviously venture capitalists and other corporates and things like that. Keep strong, keep at it. And it's the long game. It's not the short game. It's just not something I believe you're going to have success overnight, right?
Yeah. Fair. And if the shipping industry could do one thing tomorrow to accelerate decarbonization, what would it be?
I would say a few of these are doing this already, but it's to create some kind of coalition whereby they commit to large quantities of money to purchase low carbon fuels. I think the purchasing side is what the most important part to get everything off the ground and to actually finance some of these projects. So some of these are doing this already. So I'm not saying this is not the case, but there's a very long tail of shipping companies, right? So you only hear about the top 5 in the news in decarbonizing, and the rest have a very different thought process around decarbonization and obviously are very against it in many ways because of the fact they can't afford it, right? So they don't have balance sheets that can afford these kind of things. And so this is where I think there's a big issue there. Yeah, I would say that's the main thing they can do. And obviously be open to other alternative fuels and think about how they can support companies like ourselves and others.
Yeah. We're coming towards the end of the podcast now, Nicholas. Is there any question that I didn't ask that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
No, I think we covered a lot of things. No, I think we have it all covered. I like the conversation part we had around the energy pricing and what we should be doing in efficiency. I think that was an important part of the piece. But yeah,
Brilliant. Okay, Nicholas, if people would like to know more about yourself or any of the things that we discussed here in the podcast today, where would you have me direct them?
yeah, absolutely. I mean, on a personal level, of course, reach out to me on LinkedIn. Happy to have a chat about anything and everything around climate change. And of course, we have our website, xfuel.com, right? So feel free to read a little bit about what we're doing there.
Perfect. Okay. Nicholas, that's been really interesting. Thanks a million for coming on the podcast today.
Thank you, Tom. Appreciate it.